Hey, what's up, Math 1? Welcome back for part 2 of our lesson on quick graphs with intercepts. So in our last lesson, we were talking about x and y intercepts and how to do a quick graph, how to graph a function. So I'm going to flip over to the DocuCam and let's finish up these notes. You should have the notes in front of you. I'll do a quick review. Here we go. All right, so we're using these notes, quick graphs using intercepts. What we're trying to do is we're trying to graph linear equations. We want to be able to identify the intercepts. So in our last lesson, we started off, I talked with you about linear equations will show up in two formats, slope-intercept form or standard form. And for what we're trying to do, it doesn't really matter whether it looks like this or it looks like this. Remember, these are really the same graph. They're the same function, just like Optimus Prime on your notes. I've got a little Optimus Prime there. They can transform, right? It could look like this, and then it can transform over to here. And even though it doesn't look the same, it's still going to be the same graph when we graph them. So in our last lesson, in part 1, we did the kind of old school way where we created a calculations chart and we went through and we generated all these points and then we graphed the line. But what we're starting to learn is that all we need really is that intercept and that intercept right there. We only need 2 points and we'll be able to graph our line. So we started doing that last lesson and we did that. I gave you the y-intercept of -2, and I gave you the x-intercept at 5, and then we graphed that line. And then we did it again right here with an x-intercept at 4, 0, 1, 2, 3, 4, and a y-intercept at 0, 6, and we graphed our line. And one of the things that we discussed was that when you're looking at intercepts, something they have in common is whether it's the y or the x, there's always a 0 somewhere. We're going to talk about that today, right? There's always a 0, okay? All right, so let's go. We should be on page 3 of your notes right now. So let's go ahead and look at that. All right, here we go. All right, so I'm going to teach you 2 methods on how to find the intercepts. So one method I call the plug-in zeros, right? Kind of like plugging an electrical cord into your outlet, right? So the plug-in zeros. So if we want to find the x-intercept, so if the problem says find the x-intercept, well, what we want to do is we want to plug in a 0, but we want to go to the opposite variable. If we want the x-intercept, then we want to put a 0 in the y. I know that seems a little counterintuitive. You would think, well, if we want the x-intercept, why don't we plug a 0 in? But we want to actually make the y disappear, right? If we're plugging a 0 in there, then it's gone for a little bit. Okay, so if we want the x-intercept, we want to plug a 0 into the y. And then we want to solve the equation for x. And we'll do a demonstration in just a moment. So here's an example. This would be an x-intercept. We want a 0 in place of the y. We want a 0 where the y value would normally go. Okay, now, if you want to find your y-intercept, you're going to do the opposite strategy. For your y-intercept, you want to put a 0 into the x, right? So it's kind of the opposite. X-intercept, we put a 0 into the y. If I want the y-intercept, I'm going to put a 0 into the x, and then I'm going to go solve. And when I solve my equation, all I want left is a y. So here's an example. I want to put a 0 into the x value right there, okay? All right, so the reason that we plug in a 0, this is kind of important. Sometimes students don't understand this. The goal of plugging in a 0 is we want to make the variable disappear just momentarily. We're just going to kind of say to that variable like, hey, go take a coffee break. Go take a break for a couple of minutes and then come back and we'll use you, okay? So we're just plugging in a 0 to make it disappear momentarily, All right. So let's go ahead and we'll do an example here, and I'll do a couple examples. So find the intercepts and then draw the graph of the function. Okay. So here's a function right here. So instead of doing a calculations chart, we want to just find our intercepts. Okay, so we're gonna solve the problem twice. I need to solve it for my x-intercept, and then I'm gonna come over here and I'm gonna solve it for my y-intercept. So when you're doing this on your own, you've got your function, your equation, and then just draw an arrow over here for your x, and then an arrow over here. So I already have it set up for you. Okay, so if I want to find my x-intercept, what did the notes say just a moment ago, just above, right up here? What's it say for your x-intercept? Where are we plugging in a 0? Where are we putting a 0? Okay, you see it? All right, so for our x-intercept, we want to put a 0 x-intercept, not in the x, we want to put it in the y. So we want to put it right there. So I'm going to put a 0 right there. So I could draw the arrow going this way. So we want a 0 here. So 0 is equal to this. And now I'm going to solve. I want x by itself. So the first thing that I would need to do is add 6 to both sides. Then that gets canceled, right? That gets canceled. So I have 0 plus 6. So now I have 6 is equal to 3x. And now I want to get x by itself. So I'm going to divide by 3. I'm going to divide by 3. And that's going to give me x is equal to 2. Now, if x is equal to 2, what's the y? Well, we just said y was 0. So your intercept, your x-intercept is at 2 comma 0. Okay, so all we're really doing is we just want this to disappear. If I put a 0 there, then it means it's gone temporarily. Okay, so 2, 0. All right, now let's go do the same thing over here for our y-intercept. So I'm going to go cover this up. So for the y-intercept, if I want to find my y-intercept, I want y equals, then that means I need that to disappear. So I'm going to plug in a 0 right there. Okay, so putting in a 0. So 3 times 0 is 0, right? And then I get 0 minus 6. So y is equal to negative 6. And then the y-intercept is at 0 comma negative 6, right? 0 and negative 6. I put a 0 into the x. That's why I have a 0 right here. So now I can do a quick graph. I have my y-intercept. So I'm going to go and put a point at 0 comma negative 6. And I also have my x-intercept. And I'm going to go put a point at 2 comma 0. So here's my 0, negative 6. So I'm going to go 1, 2, 3, 4, 5, 6. And then 2 comma 0 is 1, 2. This is my x-axis, right? So right there. So a point, and then go ahead and draw your straight line between them. And there you go. So we didn't have to do a ton of calculations. We only had to do 2 calculations. And I'm going to show you an even faster way. Let's do the plug-in zeros one more time, and then I'll show you an even faster way called the cover-up method. Okay? All right, so here we go. We're going to do the same thing on number 14. Find the intercepts and draw the graph of the function. Okay, so here's our function, 2x plus 4. And we want to find our x-intercept. And we want to also find the y-intercept. Okay, so to find our x-intercept, I'm going to come over here. I'm going to rewrite my function. Y is equal to 2x plus 4. And then let's think about it. Where am I putting, if I want the x-intercept, do the opposite, right? We're going to put our 0 into the y. We want that to disappear. So I'm going to put a 0 there. So now I've got 2x plus 4, 2x plus 4. And I'm going to subtract 4 from both sides because I want this to get out of there. So that's gone. 0 minus 4 is going to give me negative 4. And then I'm going to divide by 2. And negative 4 divided by 2 is negative 2. And my x-intercept is at negative 2 comma 0. Negative 2 comma 0. There's my x-intercept. So I can go graph that. Let's go do the y-intercept really quickly. Okay, and remember, if I'm going too fast, the nice thing about the video is you can pause your video, right? You can pause your video. So if we were in class, I might be going a little fast for you. Okay, so y is equal to 2x plus 4, but this time I want to find my y-intercept. So I want to plug a 0 into the x, right there, into the x. So it's going to look like this. Now this is really easy. 2 times 0, well, that's 0. And 0 plus 4, my y-intercept is going to be 4. And now I need to go back and write the ordered pair, 0, comma 4, 0, comma 4. Okay, I put a 0 into the x, so we want a 0 in the x value, and then there's our 4. So now we can go and graph this. Okay, so my y-intercept is at 0, 4. So 1, 2, 3, 4. My x-intercept is at negative 2, 0. 1, 2, right there, negative 2. And then go ahead and take out your ruler or your straight edge, your credit card or student ID, and boom, draw yourself your line right there. There's your x-intercept. There's your y-intercept. Okay. All right. So that is called plug-in zeros. We're plugging in a 0, right? I'm plugging in a 0. I'm plugging in a 0, right? We got the little plug-in up here, the plug-in zeros method. Okay. Now I'm going to show you. Now we're on the last page, and this is an even faster way. It's kind of the plug-in zeros, but just with a little twist. All right, so here we go. This one is called the cover-up method. Cover-up. Okay, so the cover-up. So we're still trying to find the intercepts of a function, but if I want to find my x-intercept, instead of plugging in a 0, I'm going to just cover up the y, right? So on the previous page, I'll go back to it. On the previous page, I said for your x-intercept, plug in a 0 into the y. Well, now what I'm telling you is it's kind of like that, but for the x-intercept, just cover up the y and then solve the equation for x. And I personally actually like this cover-up method better, but plug-in zeros is important because you need to understand the mathematics. Okay, now if we want to find our y-intercept, we're going to just cover up the x. We're just going to make it disappear. We're going to just say, hey, buddy, take a break for a little bit. All right, so if we want the y-intercept, we want the x to get covered up, and then we're going to solve for y. All right, so here we go. Let's do a couple examples, and then we'll be done. Okay, so now this is an equation that's in standard form, right? X and y are both hanging out. They're on the left side of the equation, right? They're over here together. When we were doing the plug-in zeros method, this was in slope intercept form, number 13. Number 14 was also in slope intercept form. But now on this one, I'm going to show you how to do it in standard form. Okay, so here we go. We're going to do what we call the cover-up method. So if I want to find my x-intercept, right, we're still going to do x and y over here. So the x-intercept, then what I want to do, remember, is I want to cover up the y value. So I'm going to cover up the y. So what I'm going to do is I'm going to rewrite this. I'm going to rewrite it right here. I'm just going to rewrite it. But when I get to this point, now I'm just going to take my pencil and I'm just going to cover up the y right there. So I put a little green box around it. So we're just covering it up. We're pretending he disappeared, right? He disappeared. So if he disappeared, what I have left is a 3x and a 6, right? He's gone. So if he's gone, then all we have left is a 3x and a 6. Okay, he disappeared momentarily, right? I covered him up. He's gone momentarily. So now if I have 3x equals 6, then I'm going to divide by 3. I'm going to wind up getting 2. I'm going to wind up getting 2 here. So my x-intercept is 2 comma 0, 2 comma 0. Okay, now over here on this next one, Let's move over to the next one. And let me cover up our graph here for a second. If I want to find my y-intercept, then I want to go cover up the x. I want to cover up the x. Okay, so here's my equation. 3x minus y is equal to 6. 3x minus y is equal to 6. But this time, excuse me, I want to just cover that up. So I'm left with negative y equals 6. Negative y equals 6, if that's covered up like that. Now, we know that we cannot leave a variable. We can't have a variable with a negative. So we have to get rid of that. So to get rid of that, I'm going to divide by -1. So those negatives get canceled out. And 6 divided by -1 is -6. That is -6. So if that's -6 and we covered up, it's really like we put a 0 there, then that's at 0 comma -6. So we can go and graph now that we have our two intercepts. We can go 0 comma -6, that's down there, 1 2 3 4 5 6, and then we have our x-intercept at 2 0 1 2, and we can graph our line. There it is. So we just quickly took an equation that was in standard form, and we were able to graph the line by using the intercepts. Okay, we're going to do two more examples here, and your notes are updated, so they look kind of similar. I put this on here because it's kind of like this cover up. It's kind of like playing peekaboo. I don't know if you have a little brother or little sister or niece or nephew, but with a baby, it's kind of fun when they're like around 1 years old to play peekaboo with them. You cover yourself up, and they think you disappeared, right? It's kind of a fun game. Okay, so we're gonna do the same equation, but we're gonna find the x-intercept. I think on yours I put x-intercept. We're gonna use the plug-in 0 method for the x-intercept, and then we're gonna use the cover-up method for the y-intercept. I'm just trying to give you examples of how both work. So for you, you get to pick, well, right now we're gonna do them both, but then after this lesson, it doesn't matter to me whether you use the plug-in zeros method or you use the cover-up method. Both work, so you get to decide. But right now we're going to practice them both. Okay, so if I want to do plug-in zeros and I want to find my x-intercept, so I want the x to be there, I want to put a 0 in for my y, right? And it's kind of like doing the cover-up, right? Because 6 times 0 becomes nothing, right? It becomes 0. It gets covered up. So 6 times 0 got covered up. Okay, so that leaves me with a 3x and a 24, and then I'm going to divide by 3, and that's going to give me 8, and my x-intercept is 8 comma 0, right? 8 comma 0. I plugged in a 0. Okay, there's your x-intercept. And then we'll practice the cover-up method on this one. This time, it's the same equation, 3x plus 6y equals 24, 3x plus 6y equals 24. It's the same equation right there. But this time, let's practice the cover-up and let's find the y. So if I'm covering up, if I want my y-intercept, then that means I'm going to cover up the x. I'm going to do the opposite. So let's drop down here, and I put in green what we want to cover up. So if I cover that up, now I just have 6y equals 24. All I have to do is divide by 6 on both sides. I'm going to divide by 6, okay? And my y-intercept is 4. So then you have to remember to go back and put in a 0, just like we did over here. I found my x, that's an 8, so I need a 0 there. And on this one, I found the y, so I need to go back and put a 0 over here, okay? I've got that number, I need a 0 there. Okay, all right, so this last one, we're not gonna graph. This was just practicing plug-in 0 and practicing the cover-up. What you need to do is you need to write yourself one tip that you want to remember about finding intercepts. Or if you have a question, go ahead and write yourself a question, and then I'll try to look at those and we'll cover those in class, okay? All right, so finding intercepts, we have learned, today we learned the plug-in zeros method, and we also learned the cover-up method, and we were able to see that if you've got those two intercepts, then it's really easy to graph. All right, so hopefully that makes sense. If not, go back and watch the video a second time or a third time or a fourth time. All right, and I will see you guys in class. We'll talk to you later. Bye.